Okay, guys, this is grade 11. It's grade 11 stats. It's quite simple. Grade 11 stats and grade 12 stats is basically the same thing. Probably there's about 5 marks that comes differently from a different place. More of the line of regression and stuff like that. But other than that, I think it's quite simple. I don't think there's anything to panic about. And we should be able to go. So we're going to start with some terminology. We're going to learn what does the word mean. So the word mean in general in grade 11, it's the average of the data. So all we do is we will always add up everything that's there and divide by the total number of occurrences. So if there's 20 things, we divide by 20. What does variance mean? Variance means it's the average of the squared differences of the mean. But variance, a short form for variance is when you don't do stats, if you're not in university, and just in grade 12 and grade 11, variance is all you need to do is take the standard deviation and square it. I know this is not the sign for standard deviation, but yeah, take the standard deviation and square it, and that would always be the variance. Now, the next word that we learn is a histogram. So a histogram is just a bar graph, right? But all the blocks are touching. So it's a graph that represents continuous data, right? It is continuous data. And we draw histograms like this. I use the word bar graph, but I mean, you guys don't get marks for definitions. I'm just trying to make you understand. But it is continuous data. It is more of intervals and stuff like that. But that's what a histogram looks like. Now, I'm using a graphic tablet, so most likely I would never be able to draw the graphs easily. I'll try my best, but let's try and just understand the work first. What is a bar graph? So a bar graph is a graph that represents discrete data, right? It's almost the same thing. It looks like a histogram, but there is gaps in it as well. That's what a bar graph looks like. Of course, there's an X and Y axis on both, but that's okay. The next one is an ogive curve. We need to know what an ogive curve is. And an ogive curve is when you plot the cumulative frequency. Okay. We're going to learn later on about what cumulative frequency is, but it's when you plot the cumulative frequency. Okay. And the ogive curve always ends up looking something like a mini S. It's not a perfect S, but it is a S. The next one that I'd like to do is what is a frequency polygon? So just like the ogive curve, a frequency polygon ends up more like a scatter plot, but it ends up as a line, like a line graph kind of looking thing. I don't want to explain it wrong, but it does end up more like a line graph. It ends up more like a scatter plot where you join the lines. If you've ever seen a line graph, that's what a frequency polygon looks like, and it ends up using the frequency. So you end up using the frequency. Please understand the frequency and the cumulative frequency would go. I'll show you guys where it goes, but it should be fine for now. G is, what does the word symmetric mean? So when it comes to symmetric, the word symmetric in data handling means, let's say the graph for the first half of the graph mirrors the graph for the second half. So we could have something like that, and then we could have something like that. If you can see, I can cut this directly in half, and these two mirror each other. What does skewed mean? The word skewed means that when graphs, how do I put it? When the graph's taller columns lie more to the left or right. So I could have something like this. Let's put all of this here there. And then put all the smaller columns there. So this is everything's lying more to the left, or everything's lying more to the right. It's not all symmetric, it's not all even. So when the graph's taller columns lie more to the left or to the right, and the lower columns lie in the opposite direction. So it means it doesn't matter whether it's right or left. It just means one side is more skewed than the other side. One side is lying taller than the other side. One side is lying longer than the other side or smaller than the other side. That's what skewed means. And the last one is, what is an outlier? So when it comes to an outlier is a bit of data or a piece of data or a value that does not fit in with the other data, right? And this is because of some sort of strange occurrence, or maybe just because the data was written down indirectly. Like all of you on this call if you guys are, let's say, 16 years old, and if we represent that in data, most of you guys would be here. Most of you guys would be around this part. But then you get myself, or we get another student, or we get anybody that's much older than you guys. So if we're looking at the data and we put all of this lessons onto the data from Zoom, we would see that, hey, all of you guys are around the same age, and then you get one person that's completely an outlier, which would be me, because I'm teaching you guys. And that's what an outlier is. Okay. Now we're going to do the first question. It's not very difficult. But again, stats is quite difficult to draw on my screen. With a pen and paper, I'm quite old-fashioned. It's quite easy to do. But I will try my best. Unfortunately, my scale will not be correct. But where I can't draw, or where it does not look good, we will use a marking guideline to take the drawing from there, because I don't think the drawing is a problem. Right. We're going to start with the first question, right? It says below is a table with the data for the number of people driving under the influence of alcohol. Right? Look at the data below and answer the following question. What scale would you use on the X and Y axis? Now, guys, we need to know dependent and independent. If you guys understand from grade 10, those lessons, it's all explained there. You can go and watch that. But for now, let's talk about the scale. So for the x-axis, right, I would definitely, I would 100% definitely use the years here, because that's what needs to go on the x-axis. But the scale they want, what scale would you use? Maybe 2 centimeters if I could. Let's see, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Yeah, okay, 2 centimeters is realistic. 2 centimeters between each year. Okay. If I go with the y-axis, the y-axis is number of crimes, definitely. Number of crimes. And what's this going in? 2 centimeters. 70, 14 lines. Okay, cool. I'd use 2 centimeters for 10,000. Right? Or 1 centimeter for 5,000. That's all. They want us to represent the graph. Now, guys, again, I'm sorry for this part, but it's going to be very difficult for me to draw the graph accurately. So you guys just make sure on your side you got it very accurate. Right? So label, use a proper scale, and understand that marks are lost for certain things. We're going to start with 0. Right, let's go. It starts with 2024. Oh no, 2004 to 2013, right? If I can get it right, I'm happy. But if I don't, sorry, 2004. Okay, let's start with 2003 just to get it at about a part. 2003, 2004, 2005, right? I'm going to put 6 for 2006 because I'm running out of space. 7, 8, 9, 10, 11, 12, 13, right? Now, properly, I can see that my scale is not perfect because I'm using a graphic tablet. So it's hard to draw. I'm not naturally good at drawing, so it's difficult, but you guys can make it. This is going to be in thousands, right? I'm going to do the first one, but the rest we're going to count in thousands. That's 10,000. That's 20,000, 30,000, 40,000, 50,000, 60,000, 70,000. 1, 2, 3, 1, 2, 3, and then last one's 80,000. Okay. Again, guys, please draw to scale. You're not allowed to make any codes or something like what I just did here because I got no space to write. I can copy it from the guideline if you want, just to show you guys, but we'll try and draw it and then we'll do it. I'll show you the important parts and we'll work on it, right? They want us to represent the above data. So quite simply, remember marks come from labeling. So this is the years. Okay. So we can put number of years. This is the number of crimes on the y-axis. And I'd like you to learn to always label your graph, name your graph. I know this is more of a grade 8 thing, but a graph showing number of crimes versus years. So this is a lot of marks. You get marks for labeling this point, X, Y, and the name of the graph. And thereafter, it's quite simple, right? We're going to start 2004 is 24,000, 24,800. Yeah, it's not going to be fun to draw for me, but 24,800, so almost 24,900. That's 20,000, somewhere there, right? Again, guys, please draw neatly. I know you're going to look at my graph and wonder why I'm asking you to draw neatly, but it's important. Right? Histogram means the bars are touching 29,927. This one is supposed to come a little bit more this side. 29,000. So quite close to there. And it comes there. Right, so you know what I'm going to do? Because I know my graph is bad, I'm going to put the numbers in here. That's 24,886, 29,927. The next one is 31,116. So 30 is there. 31 is to be there. Okay. 31,116. So this is 31,116. That's fine. 38. Guys, I'm just going closer to 40, which is here. Okay. I think generally from the next ones, I'm just going to take it from the memo because it's a waste of time if I'm drawing all, but if you guys want to, I'll just continue. That's 48 because I think their drawings are better. But let's see what happens. 2008 going to 2009. That's 48.05, and it's going to continue, right? I think I'm just going to take it from there just to make it easier to continue because it's going to waste a lot of time and I can teach the entirety of stats in this one lesson instead of you guys looking at me drawing a histogram. Now that we got the basics of it, this is the marking guideline. I did not draw this. It's taken from the worksheet and the memos. So the graph looks a little bit better. We know that. But I don't think we did too bad. Okay. Or maybe we did. But guys, if you look at it, they're quite evenly spaced. Please understand they use like 1 centimeter or 1.5 centimeter. The 10,000 is good, but if you got graph paper, I would have went in 5,000s. I think the 5,000s would have made it a little bit easier for most of you to work with. But generally, this was done on a PC, so it's fine. There shouldn't be anything that you have a problem with. Now let's start with the first calculation question for C. C asked us to find the average number of crimes and determine the standard deviation. Now, guys, what you can do is go and calculate it properly if you want to. Most of the time, this is worth 2 marks, and you will get full marks for the calculator work. So average means mean. Average means mean. And standard deviation is a little bit different. Now, when I was in college doing stats, any of the stats that I did, we did a module in stats. Standard deviation, we had to physically calculate standard deviation. You guys do not have to calculate standard deviation properly. What you do is, going forward, we'll use those rules. You could work along, please, because I don't want you to get lost. We're going to go with mode. We're going to press mode. We're going to press the button that says stat. You're going to press the one that says one variance. You're going to press the one that says one variance. Yeah. Okay. Then you're going to get a column. After you press one variance, you're going to get a column that looks like this. Right? You're going to get a column that looks like that. And you're going to start adding it up. So we're going to start entering the values of the number of crimes. Do not add the x-axis, add the y-axis, right? I know it says x there, but add the number of crimes. So we're going to start putting it. We're going to go 24,886 and press equal, right? So we're going to start to add the numbers, add a number, and press equal, right? And unfortunately, these steps you have to memorize because they're not going to put it in the exam. So we're going to add a number and we're going to press equal. So I'm going to put 24,886 and press equal. 29,927 and press equal. Please don't make a mistake with adding the values. 33,116 equal. 38,261 equal. 48,405 equal. Double check everything. It's easy to make mistakes with this. 56,165 equal. 62,939 equal. 66,697 equal. 69,232 equal, and 71,029 equal. So when you're done with all of this nonsense, the next step seems a bit annoying, but you're going to press AC. It does not cancel anything, but it does clear the screen. When you press AC, the next part is to press Shift and the number 1. So you're going to press Shift and you're going to press the number 1. And after we do that, you're going to look for the one that says variance. Right? I don't know if these steps are confusing you. I'm trying to walk you through it, but if you guys are confused, you'll let me know and I'll just type it out. You're going to find the one that says variance. In my one, it says number 4. And now we are good because the one that looks like X is the mean. So the mean looks like the X like this. The standard deviation looks like the squiggly line that looks like this. And we should be good. Let's start with the mean. If I press 2 and if I press equal, I'm going to get the mean as 50,066.7. And if I go back and press AC, Shift, Stat, Variance, and now I do the standard deviation. Please don't think S and X is a standard deviation. It's not. You press there, and we should get the standard deviation of 16,599.15. Now, this is very important. This is very, very important because later on, there are other questions that they can ask you to calculate the range between one standard deviation. Okay, so what that means is, or calculate the range of the mean between one standard deviation. So what you would do is, I know this is not part of the question, but you will see it often. You'll take the standard deviation and you would add the mean to it, and you would get an answer, and you would write it down. Let's just do it for this question. Okay, let's just do it, right? We take the mean. We can go both ways, right? I just want to confirm. We take the mean for now, right? The mean is 50,066. Again, this got nothing to do with the question, and we're going to add one standard deviation to it. So if we add one standard deviation, we get an answer. And then we're going to take the mean and we're going to minus one standard deviation from it. And this would be a range. This would be your level 4 question for these type of questions. I'm just letting you all know that we can get the range quite simply. And then you would get an answer here, and you would write it down. And then you'd get an answer here, and you would write it down. And they could ask you to count the number of people in that range. But for now, we'll stop. We won't worry about this. We'll come back to it when we're doing exam questions. For now, the next question says, looking at the histogram, would you say the general trend, what would you say the general trend is, and why would you say that? Now, if I look at the general trend of the histogram, what I can see is that I can see the crimes are increasing every year. So the general trend is that the number of people driving under the influence of alcohol is increasing. Why do I know that? I know that because the the histogram is increasing. The columns are getting bigger as it moves to the right. Okay? Now that's fine. And then, is the data skewed to the left, skewed to the right, or symmetrical? Now, guys, I'd like you to work with this. I'll explain it a little bit later. But the skew part for this graph is we look at where the columns are going smaller. We look at the taller columns where more of the data is grouped. We can see more of the data is grouped here. So this is skewed to the left. It's negatively skewed. Okay, this is skewed there. It's we can say it's negatively skewed, or you can say skewed to the left. So we need to know the general trend is to the right, but more of the columns are moving up. It's moving up to the right. So it means the graph's more skewed to the left. The general skew is more negatively skewed. Okay, guys. Given below is the petrol prices from January 2010 to October 2010. And this was good petrol prices. Study them carefully and answer the following questions. Right? So they gave us 16th of October 2010, 6th of January 2010. Now, guys, again, the first question wants a histogram. I'm not going to draw it because it's going to waste time, and you guys are going to just be sitting and looking at me draw a histogram. So what we're going to do is I took it from the marking guideline, I put it here, and we'd work on it from here. The important parts to notice is that there is always a label to the graph. There's always a graph name. I prefer saying graph showing the cost of petrol from year to year. That's fine. It doesn't matter what you do. That's just the way I learned it. On the y-axis, please choose the right thing. The cost of petrol, the one that's going to change is going there. And the one that's set, the months are the months. Use that for the x-axis. We can do a theory lesson, or we can look at the grade 10 stat lesson that shows you where to plot each point. But our histogram would technically end up looking like this. Now, I don't want you guys to use this video and to just copy. I want you all to physically draw the histogram because it's going to take time to practice. But also stats is the first and second question in your paper in grade 11 and 12. It's the easiest question, but it's also the question that wastes the most time. So you need to learn the calculator work and you need to learn the drawing very quickly. Say like this, I know the calculator work. I'll rewrite it because it's a teaching lesson. To get the mean and the standard deviation, it's quite simple. You're going to press stat. Okay, let's go. You're going to press mode. You're going to press stat. So let's go again with this question. We're going to press mode and stat. After mode and stat, we're going to press variance. So you should see one variance. It won't, maybe it'll always be one. You're going to enter values. So enter. Let's enter our values, right? So I get 7.96 equal 7.92 equal 8.02 equal 8.01 equal 8.27 equal 8.54 equal 8.40 equal 7.91 equal 7.85 equal and 7.67 equal. I know I'm moving a bit fast with the calculation part, but you guys, I've seen most of you on TikTok, Instagram, and WhatsApp. You can also type and scroll fast, so I'm sure you can learn to use a calculator fast. But press AC, guys. This clears the screen, not the answers. We're going to go with Shift 1. We're going to go with variance. I'm putting variance in case on my calculator it's number 4. On your calculator, it could be something else. And we're going to look for there, the mean, which is number 2 in my calculator. And I got 8. So I got the mean is 8.07. Please remember that this is the symbol for mean. The standard deviation is that one. And the standard deviation should be, you're going to have to press AC again, Shift 1, go to variance, press the standard deviation is that sign, and equal again. And the standard deviation is 0.25. Right? Is the histogram sorry guys, skewed to the left or the right? And or is it symmetric? Now for me, English is not working today. There's too much of numbers, but for me, generally, you see, both sides are technically going to the center. I could debate and say either way, but for me, I would say it's generally symmetric, right? Because it's not skewed. It's not like one side is going higher. Yeah. It's not like one side is going higher like that. Or it's not like one side is going lower. It's both of them are ending up towards the center. So the biggest part of this graph is towards the center. So I would say generally it is symmetric, but it doesn't always have to go like that. Sometimes, I mean, it could start off here, go down low and then end up going back to the top. So it depends. I could see it's generally symmetric. It's up to you guys. But okay, the next question. Okay, guys, we're moving on with the next question. The next question generally, it is okay. A lot of mistakes though can be made. We're given a table with different African countries and the percentage of children below the age of 5 that are underweight. First, it's measured between 1993 and 2000 and measured a second time between 2005 and 2008. It's taken from the data collected by the World Health Organization. Guys, this is a very old paper, so data probably most likely is not accurate. They want the difference. Now, the difference you do not have to go and you don't have to go and try and make anything positive. It doesn't matter for now. So what you would do first is you would just take this column, the first column, minus the second column, just to make it easy. So 37 minus there is 21.4%. And we would continue going down. Okay, so the next one would be 3.9%, 1.2%. So let's go 3.9%, 1.2%. And no, I'm not calculating this. The reason I'm doing it so fast is I have the answers. And so you guys need to understand, be realistic as well. It's not always going to be able to be done like super fast. So take your time, double check. We don't want to make mistakes, especially in a question where the data determines everything. So that there, 2.3%, that's 11%, 9.8%, minus 0.7%, 4.7%, 10.2%, and minus 2.5%. Okay, guys. Now, what I'd like you to know is that you should always double check this data. It's really important. And if you don't, we're going to make a mistake now. Question A said to find the difference. Now, when it comes to calculator work, when it comes to you entering values into the calculator, you don't have to go and put stuff from smallest to biggest. But when it comes to you physically calculating something, the rule is everything needs to go in ascending order. That means you have to start with you have to physically start with the lowest and go to the highest. So we're going to draw a box and whisker diagram to represent the plot from 1993. Let me leave this dot here. I'll move it now. 1993 to 2000. So we have to go and put everything in order. Now this part, it is annoying, but scratch out. Go and scratch out lightly with your pencil. Don't use a pen. If you make a mistake, it's going to cause a problem. Let's start putting stuff in order. That's 8%, 11.5%, 15.1%. This is work that you guys did from grade 2, so grade 3. So please don't make mistakes, double check. 18.9%, 19.6%, 20.4%, 25.1%, 26.5%, 26.9%, 28.1%, 30.7%, 37%, and 42%. Again, please be realistic. I did this very fast because I did this question a lot of times and I had the answers written down already. So that's why I was able to do it this fast, but it's not going to take you this thing. You're going to have to go step by step. Go through 8, then go through 11, then look at the rest of it and go 15.5. Then you're going to look at the rest of it and go for the 17, 17.6, 17.8, 18. It's going to take you a while. It's not going to be done in 5 seconds or 10 seconds, right? The next is you and I need to learn something. This part might be a bit difficult at the start, but I'd like to teach you a formula that maybe you didn't learn as yet, or maybe you did learn, and that's fine. But we need to learn to deal with any box and whisker diagram needs a 5-number summary. Now, for the 5-number summary, we need to get the minimum. We need to get the maximum. So quartile 1, quartile 2, quartile 3, and the maximum. So the minimum is 8%. That's fine. The maximum is 42%. That's okay. That's not fine because this is underweight children, but I mean the answer's fine. Quartile 2 is the median. So you learned quartile 2 is the median. Now, guys, there's multiple ways. We can go and physically count and say, hey, 1, 1, 2, 2. Like I can go and do that. And then I'd end up with the max. I'll end up as quartile 1 as 17.6%. I'll end up with quartile 2, the median 20.4%. So basically, we would find the middle term. That's quartile 2. And then we would find the middle of quartile 2. That would be quartile 1. I'm going to show you guys now with a simple term and a simple way to deal with it. But I'm also going to show you, I'll show you guys a very easy way to do it as well. And quartile 3 is 28.1. This is quartile 3. Now, before we come to this 5-number summary, I'll pick, I'm going to do an example. Let's actually move this out the way. And let's do some easy numbers, right? So what's going to happen is I'm going to pick some easy numbers. I hope it's, let's say 3, 6, 9, 12, 15. Okay. So let's pick 2, 6, 8, 12, 15, 18, 1, 2, 3, 4, 5, 6. I'm trying to make it as easy as possible. 18, 20, 21, 25, 30. That's 2, 4, 6, 8, 10, 31. My birthday. Now, normally, our 5-number summary would be the minimum is 2. The maximum is 31. That's fine. The quartile 1, quartile 2, quartile 3. Quartile 1, quartile 2, quartile 3. So quartile 2 is the median. How do I get the median? What I do is I physically go and count 1, 2, 1, 2, 1, 2, 1, 2, 1, 1, and I get the middle value. And that is quartile 2, the middle value, which is 18. Now, I can go and get quartile 1 and 3, because quartile 1 and 3 is technically the middle of the first half. So let's go again. 1, 2, 1, 2, 1. So that is quartile 1. And if I go this side, 1, 2, 1, 2, and the middle of this side is quartile 3. Now that's what quartile 3 and quartile 1 is. But there is something else. There's 2 other parts of stats that we need to remember from grade 10 is range. Range goes maximum minus minimum. That's easy, right? 31 minus 2. And that's 29. And then we get interquartile range. Interquartile range is Q3 minus Q1. It's going to take some time, but after practice, we're going to get it. And this is going to be 25 minus 8. And the interquartile range equals to 17. Now, why did I teach you this? Because it's important. But in grade 10 and 11, it's very easy to do this. But what happens when you have 50 numbers or 20 numbers or difficult numbers? Do we have to keep using this formula? Maybe, maybe not. Let's go and copy this. Let's try and do it a different way, because there are other ways to do the exact same question. So let's remove all of this and let's learn one formula. Now, guys, what I'm about to teach you is the position formula. So please understand, we have to count. So the minimum is still 2. The maximum is still 31. Let's talk about quartile 1. Let's talk about quartile 2. And let's talk about quartile 3. So for quartile 1, I want you to go 1 over 4 n plus 1. For quartile, okay, let's go. Should I not? Should I? Yeah, okay, let's go. 2 over 4 n plus 1. I'll confirm, right? Because I didn't use this formula in a long time. 3 over 4 n plus 1. Let's go and see if it works, right? So what's going to happen is we're going to count the number of terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we're going to do this. We're going to say, okay. We're going to say 1 over 4 into 11 plus 1. And this should be 1 over, sorry guys. Let me reset my calculator. My calculator is being a bit iffy with all of the work we did, but we should be good. 1 over 4 times 11 plus 1 is 12. So that should be 3. Now I want you to understand that the quartile 1 is not 3, but we're going to count 3 spaces. 1, 2, 3. This is quartile 1. Let's try the next formula. Quartile 2, 2 over 4, 11 plus 1. And this is going to be half of 12, which is 6. So let's count. 1, 2, 3, 4, 5, 6. And this is quartile 2. Remember, guys, this is position. You have to physically count the parts. Right? Remember that is position. And 3 over 4, n plus 1. And this should be most likely, let me just do it just in case I'll make a mistake. And this is 9. So we physically count 1, 2, 3, 6, 7, 8, 9, and that's quartile 3. And this is how we use these formulas. Now, again, this is position. Please count. This is position. So count. That's not the answer, but you guys are able to use any method that you want. It's up to you to decide what you want to use. What works for you works for you. Physically counting works. Using the formula works. It depends on you guys. So we're going to move on with the next part. What's going to happen is quartile 1. I'm going to use my formula. Quartile 1 is 1 over 4 into 15 plus 1. And that should equal to the fourth term, right? That 4. And this is position. It's not the answer. The answer is 17.6. The median, we can use 2 over 4. N plus 1, which is 15 plus 1. That should be 8. Again, this is not the answer. This is position. So it's 20.4. For quartile 3, I'm going to use 3 over 4. N plus 1. And this should be for a 12. This is not the answer. That's position. Count 28.1. Now they wanted us to draw a box and whisker diagram. So this is where the important parts come up. Is we need this 5-number summary because this controls the box and whisker diagram. Now I'm going to move it here. Let's try and draw it. So the box and whisker diagram for question B is going to look something like this. It's not too difficult, but you have to give a very realistic drawing. So we're going to start off with our line that goes there. We're going to look at our numbers. We're starting at 8. We're ending at 40. So maybe I'm going to go in 5s. Maybe 5s work. Maybe 10s work. But I think 5s. Let's go with 0. Let's go with 5, 10, 15, 20, 25, 30, 35, 40. Let's go with 45. Okay? When it comes to the box and whisker diagram, I need you to understand that the minimum, which is 8, is somewhere there, right? You will draw an asterisk for the minimum, and you will draw an asterisk for the maximum. So that's, you don't have to put numbers, but I'm going to put it just so you guys can see that was 8 and 42. You don't add the numbers to the box and whisker diagram, but it is fine. The next part is to draw the lines for the median. The median is 20.4, which is there. Ooh, a little bit less actually. 20.4. What is the quartile 1? 17.6, somewhere there. Okay, I shouldn't have drawn that. And the max, the quartile 3 is 28, somewhere there. So now this is our box and whisker. Now my box and whisker diagram looks quite questionable, but generally if you're drawing it with pen, paper, it would be good. Now guys, this is quartile 1. Quartile 1 is 17.6. This middle line is quartile 2, which is 20.4. And the other line is quartile 3. Now, I know they did not ask you this as yet, and it's fine, but I would like to teach you something before we move on, okay? Each part of this data is worth 25%. So this line from year to year is 25% of the data. Again, this is not really taught really well, so this is 25% of the data. If we look at this line, even though it's not the same size, that's 25% of the data. This is, I'm just using yellow and green to alternate so you can see the colors. That's 25% of the data. So that's 1/4 of the data. And that's 1/4. So again, even though they're not the same size, even though things are not going perfectly, they are all worth 25% of the data. They are all 1/4 of the data that we deal with. So we need to remember that for level 4 questions. Now, guys, this was the first one. Question B is done. They want us to draw a box and whisker for 2005 to 2008. It's going to take some time to do it. I'm not going to do it. I'm going to put the answers on the screen because it's the exact same thing as the other one. What would happen? Theirs is a bit different, but what would happen is we would label the data. We would label the data from from smallest to biggest. We would go and we would find our quartile 1, 2, 3, 4. 1, 2, 3, 4. Quartile 1 is 14 because we used our formula. That's quartile 1. We would find our min. There's our minimum. We would find our max. There's our maximum. We would find our quartile 2, which they gave to us here. Median is 16.6. That's quartile 2. And we would find our quartile 3 with 18.4. Now, all of this could have been done. You put it from smallest to biggest. You do your 5-number summary and you find it. I would like you guys to try this on your own. The question says, the question says draw a box and whisker diagram for 2005 to 2008, but we're also trying to save time. We don't want to do a 1-hour video with me just counting numbers. So it's done. I prefer the asterisk on the end. That's the way I was taught. I would prefer you guys understanding that's quartile 2, quartile 1, quartile 3. And we start to answer questions. Let's answer some questions, okay? They want us to compare the two box and whisker diagrams. Now, genuinely, their one looks a bit neater than mine, but that's not what we're comparing. What we're comparing is the skewness of the box and whisker diagrams, okay? Now, if I look at it, I want you guys to understand the second box and whisker diagram, 2005. So let's call this the 2005 box and whisker diagram. And this is the 1993 one. Right? If we look at the box and whisker diagram for 1993, their data is more spread out. It starts at 5, it starts at 8 and it ends up more at 40. The data looks like it's more spread out. Even though both looks almost the same, we can see that 2005 is a little bit closer together. The data starts at 8 and it ends at 34. So it is more squashed up. It is closer together. The spread of data is there. If we look at it, more than 50% of the second set of data, right? We're going to start talking about the 25%, the 50%. We're going to start talking about a lot of stuff. But we can see that more than 50% of the second set of data lies within the first quarter. So we can see that even if we start counting, I'm going to remove all of this, guys. And you guys start to look at the data and we can see, let's go 1, 2, 3, 4, 5, 6. Where's quartile 2? There. 3, 4. There. So more than 50% is lying in the first half, in the first 25%, right? So you can look at it, you can talk about skewness, we can talk about the maximum, we can talk about the minimum, we can talk about the fact that the second one's maximum is still smaller than the first one. We can talk about which has a lower maximum, which has a higher minimum, where the data is spread out, which one is more skewed. Generally, for me, I think this is quite similar. It's not too different, but we can see that the first one has a smaller spread of data, and the second one has a bigger spread of data. But this was a bad question for theory. To be honest, it was a bad question for theory because the box and whisker diagrams are quite equal looking. But we will work on more questions. We'll work on questions where they're completely different. and you're able to see the difference. So we'll work on that. The next is, okay, are there any outliers? Are there any outliers in the data? And the truth is, yes, there is. There is an outlier. Why is there an outlier? Because you can look at it in the 2005 one. All of the data is quite close to this, and then you get this one outlier that's very far away. The same thing could have been said for the 42. Everything's so close together, and the 42 is very far away. So was there an outlier? Yes, there was an outlier. The outlier is for 2005. It has an outlier of 34.6. I would also consider the outlier as 42. I would consider the outlier of year 42, but we can see this is a very big difference. So it doesn't matter for this question. Specifically, it's a practice question. So if you told me 42 is an outlier, I would take it. If you told me 36 point, whatever the maximum is, what's the maximum? 34.6, I would take that as well. So I accept those ones. Draw a box and whisker diagram for the differences of the two. Again, this one is quite simple. We would use this column to draw a box and whisker diagram, and we would start to work on it. But I think that's just going to waste your time, and we're going to end this video after the next question. So the box and whisker diagram that's here would be this part here. Okay, this is for the differences. We can see that it's starting at a negative number and it's ending at 21.4. We know how to calculate quartile minimum, maximum. We also know how to calculate quartile 1. We know how to calculate quartile 2. And this is quartile 3, and quartile 2 should be 3.9, right? So this is min, quartile 2, quartile 1, max, and quartile 3. Guys, I'm not doing these questions over and over again because you guys can practice. We can refer to the first one, and it's quite easy to get it. But the last question for the box and whisker diagram here would be, what do these box and whisker plots tell you about nourishment of children in the countries under the age of 5? You see, the box and whisker diagram, it shows there's a decrease in the number of children under the age of 5 that's undernourished. You can see that the kids are not struggling so much. Between 1993 and 2008, you can see 25% of the countries are shown to have an increased number of children that are undernourished, but 75% of the countries improved their undernourishment. Now, for this one, I'd like to do a theory lesson. We're going to try and do a 2-part lesson. So this is going to be part 1. Part 2 of the video would be, or part 2 of the lesson would be frequency polygons. It would be OJF curves. It would be frequency and cumulative tables. But I would also like to add box and whisker diagram theory for you guys to understand. But we're going to end at this point.